Welcome to microprocessor and microcontrollers lab. So in this lab, in this lecture, I am going to give demo on microcontrollers lab. So in NPMC subject, already we have studied about the microcontrollers. That is MSP430 microcontroller. So here you can see the MSP430 microcontroller board. So this board contains MSP430 G2553 microcontroller. This is the microcontroller, right? This is the microcontroller. So using this kit, we are going to do the experiments in the lab. So to do the lab experiments using this kit, so we need some software requirements. We need some requirements. That is, software requirements are required and hardware requirements also required. So let's see what are the requirements to do this microcontrollers lab. So coming to first one, software requirements. What are the software requirements? We need a software tool, right? To in a generally we need to perform to work any task. We need tools in general. Likewise, so for microcontrollers lab, we need a software tool that is called Code Composer Studio. It looks like this. So this Code Composer Studio software is developed by Texas Instruments for all their processors and controllers. Next, hardware requirements. Coming to the hardware requirements. So this one, MSP430 microcontroller, that is MSP430 G2553 launchpad. This is look like this, right? There is a top view, and you can also see here like this. This is the kit, right? And inside this kit, what we have this one. This is the microcontroller board and USB cable. So here a USB cable is required to connect the microcontroller with PC. So yes, our personal computer or laptop. So you can connect by using this USB cable or the microcontroller personal computer or laptop. You can see like this. So these are the software and hardware requirements required to perform applications, programs to run programs on microcontroller, MS432 microcontroller. Right. Now we'll see the microcontroller, what is the board contains. So this is the board, microcontroller board. In this board you can see MSP430 microcontroller. You can see it is a 20-bit IC. This 10 pins and 10 pins are there. And in this board, this board has onboard push button switch, right? This switch is an input device to the microcontroller. It is already interfaced, or it is already connected to port 1.3 pin. Yes, the microcontroller has general purpose input output pins, GPIOs we call it as. So they named it as port 1 8-bit port, port 2 port 3, port 4, like this. So here the port 1 P1.3, that is port 1 third pin is connected to interface it to push button switches, and at the same time the P1.0 and P1.6 port 1.0 and port 1.6 pins are connected to LEDs. So LED 1.0 is connected to red LED, 1.6 is connected to green LED. So this board contains a on board switch and onboard LEDs already connected, right? So here this is the microcontroller part and this one is emulation part. So this emulation part will take care of the connecting the microcontroller to the PC and downloading the program, right? Downloading the program and debugging, everything is taken care by this emulation board, right? So now we'll see. It has a reset button here, right? You can see the port 1 pins and port 2 pins, all these things in this board, right? So coming to the functional block diagram of MSP430 microcontroller, it looks like this. Already we have studied in theory also, right? So this is a CPU, 16-bit CPU has 16 registers, right? All are 16-bit registers, right? And this is a RISC CPU. You can see MAB is memory address bus and MDB memory data bus. So these are the clocks, right? 3 clocks are there. M clock is connected to the CPU, and you can see this is the memory, flash and RAM memory, and these are the IO ports, and ADC is an analog module, comparator is an also an analog module, and timers, watchdog timer. So these are all comes under digital. This is for serial communication, USCI, and there is SPI, right? SPI I2C, right? So it has two modules, USCA A0 and USCA B0. USCA E0 module supports UART, ARDA, SPI, LAN, and this USCI B0 supports SPI and I2C protocols, right? This is a functional block diagram. And coming to this uh, pin diagram of MSP430 microcontroller, you can see here the pin diagram, right? Total 20 pins are there, right? So now you'll see the software tool. This is a Code Composer Studio. So it's the icon for the Code Composer Studio. And if you open this, first you'll see this one, this, right? And you see the Code Composer Studio. The Code Composer Studio is the integrated development environment for the whole span of Texas Instruments microcontrollers, DSPs, and application processors. So the Code Composer Studio includes a suite of tools used to develop and debug embedded applications. So for all devices families, CCS includes compiler, source code, editor, project, build environment, debugger, profiler, and simulator, and many other features, right? CCS. So in our lab to do experiments, we need a CCS 6.1 and above versions. CCS 6.1 and above versions, right? Right. So if you click on this icon, like this is the icon. If you click on this icon, immediately it will show like this, Texas Instruments, and it takes a few seconds or minutes to load the program, the application software. So like this, loading device information, it will show like this. Next, so after loading it, then it will display this one, this is screen, right? You see CCS editor, right? This is a file name. You'll see how it comes, right? So here in this window, the CCS Code Composer Studio perspectives. There are two graphical user interface perspectives. Two perspectives are there. One is edit perspective. Second one is debug perspective. What is edit perspective? So in the edit perspective, the edit perspective has menus, buttons, and editor window to edit the source code as shown figure. So these are the buttons, files, right? View, edit, navigate, windows, all these are menus and buttons. You can see these are the buttons. Save button, this is save button, save all, right? This is a build button, debug button, right? Likewise all these buttons are there. And this is a project explorer. You can see what are the project you are created, and what are the source files and projects, you can see clearly here, right? And the libraries and everything you can see here under project name. So this is area editor. We can write the program in this area, right? This is a editable area here, and you can see this is edit perspective. Here two buttons are there, that is CCS edit and CCS debug. So while we are entering the program, it will be in CCS edit. This button will be highlighted, right? Right. So here, if you enter the program, if you enter all the program, then what we have to do? We have to save this one. Save button is this one. We have to save the program. Then immediately we have to click on this hammer button, that is called build button. Hammer button is nothing but a build button. We should click on build button. So if you build, then what happens? It will show any syntax errors or logical errors in the program. If logical errors or syntax errors are not there, then it will show the build finished, right? Build finish. So after build finish, you need to, this is a microcontroller, this is microcontroller board, and this is a USB. So you need to connect, you must connect, right? You must connect the this one, right? The kit to system. So if it is working, it will show the green light power supply indication. Green light, it's working, right? It's working. Now we'll see after connection. So that's why I have mentioned here before going to click on debug. So the second button is debug, right? So debug, we must connect the MS430 microcontroller kit to PC. We should connect. That is the first step. Don't forget. So now coming to the edit perspective, debug perspective, right? So here, after connecting the kit, we have to click on debug, this button. The bug button is there, this button. So if you click, what happens? So it will connect our interface, the PC, to the this microcontroller, and whatever the code we have written, that will be converted to the output file, executable file. The executable file will be loaded into this microcontroller internal memory, right? Internal memory, then and it is ready to work, and then it is ready to work, operate, right? So now, after clicking the debug, what we'll get this window. After clicking the debug, we'll get this window if the kit is connected to the PC or laptop. Then only we'll get this window, or else we didn't get, right? So now, this is here also you can see the buttons and menu buttons here, right? These are the buttons, save button and other buttons are there, and these are menus, right? Here you can see this debug. You can see the debug here, what is the board we have connected, and programs, everything will display here, and you can see redo or undo buttons also here. So this is very important. This is play button, green is play button, next pause button, terminate button, right? After clicking the debug, if everything is okay, then what we have to, it will show this one, and here CCS debug, this button will be highlighted. Now we are in debug perspective. So if you click this green button, then this will work according to the program loaded into the microcontroller, right? So to see the register contents, internal register contents, what we have to do, we have to click on pass. We have to click on pass button. So we can see the registered values. Then if you want to stop, then if you click this one, terminate button, if you click the terminate button, then we'll get, it will switch it to this edit mode. Automatically it will come to this state, automatically come to this window, edit perspective, right? So this is about code composer studio, how we have to work. So next, how to create a program in project in code composer studio, we will see. So first you click on file menu, and then click on new CCS project. Then it will show this wizard. So here you have to select a microcontroller number, MSP4. There are many microcontrollers developed by Texas Instruments, so you need to type this number, select, right? And you have to enter file name here, right? Here file name, then you click on finish. It will show, afterwards it will show like this. It will show this one. And the file name will be, project name will be highlighted here, and here you have to enter the program. You have to enter all the program, right? All the program. So after program is entered, then what you have to do, you have to build, and then you have to connect the kit, and then you have to debug it and verify the output. So that is what we have to do using the CCS tool and microcontroller kit. Now the first experiment is to blink an LED with GPIO, right? To blink an LED with GPIO. So already, so this block diagram shows this is a MS430 microcontroller, CPU, GPIOs. P1.0 is, that is this pin is connected to, already interfaced with red LED. P1.6 is connected with green LED. So we, in this program, we are going to blink, glow the red LED. So if you want to glow the red LED, the P1.0 pin should be 1. So if you want to switch off the LED, the P1.0 should be 0. So the microcontroller here, the microcontroller should send P1 on P1.0 10101010. Then only the red LED will be on off. It will function on off like this, right? Right. So to do this experiment, we need to configure IO ports. So to configure IO ports, there are some registers are there. So to blink an LED with GPIO, we need a PXDAR, that is port direction register. Port direction register, right? So this is the port direction register P1. P1, right? Actually, this is a port in the kit. This is a port P1.6 connected to green LED, P1.0 is connected to red LED. Now, so here, so this is a P1 DIR, P1 port 1 direction register, port 1 direction register. So the LED is an output device to the microcontroller. So the P1.0 or P1.6 should be set to output direction. So to set output direction, the particular pin P1.0 should be 1 for output. To set input direction, to select input direction, this pin should be, we have to give this value should be 0, right? Likewise, I have mentioned this is for to glow, right? A red LED, the direction register should be configured like this, and for green LED, the value should be like this, and for both LEDs, this is the condition, right? So 0, we have to give 0 1 to the port 1 direction register for red LED. For green LED, we have to give 4 0, and for both LEDs, we have to give 4 1 direction, right? Right. So that means here 1 is there, that pin will be in output direction. 0 is there, that pin will act as the input pin, right? Now, so this is the flow chart for this program. Flow chart. You can see here the flow chart. Start, disable watchdog timer. So in all applications, we should disable watchdog timer, or else it will restart. Right? It will generate a reset. Right? Reset signal continuously. So that's why we need to disable watchdog timer, first step, right? And set P1.0 because it is connected to red LED, so it should be set as output direction. Then toggle means P1.0, we send a 0 or 1 or 0 or 1 0 or 1 like this data. So we have to toggle this, we have to toggle P1.0, right? For that we have to write functions, right? So means in the program for disable watchdog timer we need a function, and to set P1.0 we need to write a function, toggle we need to write, and delay we need to write. So after some delay it will go and again it will toggle P1.0. That means, for example, if 0 is LED is on for 2 seconds, then it will off for 2 seconds, and then it will on for 2 seconds, and then it will off for 2 seconds, like that it will flow, right? So now this is a program, this is the program. First step is, right, in main void, right? So there is a header file we need to enter, header file also is there, and in the main watchdog timer control register WDT CTR control register is equal to watchdog timer password. We need to give password. If you don't give password, it will generate another reset signal. It's also generate power up clear signal, right? So watchdog timer password or operation is watchdog timer hold bit. So what happens, the watchdog timer hold bit will goes to 1. Then what happens, the watchdog timer will be in stop condition. Next, this is P1 DIR port 1 direction register. So this is our operation is equal to 0x01, right? So that means 01 means this one, you see 0000001, so 01H. So we have given here 01. So set P1.0 to output direction, right? So this is infinite loop, while y means we are putting infinite loop here. So volatile unsigned int I, right? And now P1 out is equal to P1 out is equal to this is cap symbol, that is XOR. For our XOR operation we use this symbol, and 0x01. So toggle P1.0, right? This will toggle P1.0, and I is equal to 50,000. I have delay given delay, software delay. So do I minus minus minus. So the I will be decreased until I is equal to 0. It will run this loop, right? So this is the operation. What is going to happen when we run this program, right? So next we'll see the CCS studio, how it is going to happen, right? So first, create new project. To create new project, click on file and then new, and then select CCS project, right? And then select CCS project. So now it will show. Now in this in this wizard, new CCS project wizard, you need to enter, select the microcontroller for the type MSP430 G, smaller capital, no problem, G2553. So this is the microcontroller we have, and then you enter file name, for example BLI blink LED, blink LED. I have, right, blink LED, blink LED. So everything okay. BLINK, blink LED. So already that's a project, that's why it is not LED. Yeah. So new name I have given, finish, will finish. So immediately it will show like this. You can see CCS edit perspective, it is highlighted, and these are the buttons we have. So now we have to type, enter the program. So this is the default program. So now I will copy the program, right? Start typing and copying the program. So select this one and paste it, right? So you can also use here MSP430 G2553 also you can enter, right? So now I copied, I entered the program as it is, right? And then what we have to do, save. This is save button, and then what we have to do, build button. Click on build. So if you click on build, if there is no technical errors or there are no errors, then it will show this build, finishing build target, blink LED and out, right? The file is, output file is ready, build finished. So then what we have to do, then you have to connect this kit. Then next step is we have to connect this kit to the PC laptop. I already connected, so I am getting green, right? Light is on. So then you have to click on this debug button. Click on debug, right? Click on debug. So now it is changing from design edit perspective to debug perspective, and it will ask this one. Okay, click on proceed, and it will configure the debugger. It will take 2 3 seconds. That is depends on the RAM, the memory capacity of our system, right? If you have more RAM, it will work, respond very quickly, right? So now we'll see. Now it is in this condition. Now program is already loaded into this microcontroller. Now what we have to do, we have to do, click on this button, play button, green button. You see, you have to click on play button, then it will start working. So now I am clicking play button. So now the red LED is glowing. Red LED is glowing. Now I have used port 1. So we'll see the contents of registers, right? I have passed to see the registers. What I used, port 1 registers, right? You click on port 1. So each port 1, each and every port has group of registers, that is P1 in, P1 out, P1 DIR. We have given P1 DIR 0x01. Here you can see this one. 0x01 P1 DIR. So same thing is here, right? And our other registers also you can see here. And this is the port 2 register contents. Don't bother about port 2, port 1. P1 DIR is 01, right? So P1 out, all bits are 1 now, right? And we'll run same and we'll pass. Okay, now we'll see here. Now it is LED is on condition, off condition. P1 out is FE. FE means LED eligibility is 0. That is light is off, right? So we'll play. So now it is working. Now after seeing the output, observing the output, then we'll terminate. Don't remove the board from this computer. So after clicking on the terminate button, it will come to the edit perspective. Edit perspective, right? So now we'll change. Now I'll change for to what? Which one? Green LED. That is P1.6. Now I am changing. Even output direction also I have to change 40, right? That is 6th pin P1.6, right? Now let's see. I will build the save build, right? After build, if has no errors, right? Build and debug, everything okay. It will show class proceed, right? We'll configure debugger. So configuration, everything is okay. Then click on resume button. Right now, green LED is glowing. You see, you can see the green LED is glowing, and you click on that pass button. You click on registers. So P1 out. It is showing DF. Now value is changed. Right, P1 DIR is equal to 40. Whatever we have given, same value is there. Right. So then we'll terminate. Right. So again I will change. For example, if you want to use 4, we have to give 4-1 for both LEDs. Is a 4-1, right? So build automatically, it will save. Automatically, it will save. So after building, now we'll click on debug. It will stop. This kit will stop, right? Now it will. After proceed, it will stop. After proceed, it will stop. Right? Now it is stopped. Now, if you click, see, go it's glowing alternatively. Yes, both are glowing alternatively. Red LED and this one, right? So we'll terminate. So this is about microcontrollers lab demo and experiment 1.